There was a rogue mathematician who kept the secret of a breakthrough invention to himself.
You just want to keep it to yourself for a while, because for a while you're the only person on earth who knows something. And that little secret is just so exciting. But then, of course, you want people to know, and you want people to start using it. It was something that was kind of hard to grasp and believe, because I've been looking for them for so long, and all of a sudden, it happened. And moreover, then, the theory just really started rolling, looking at asteroids, comets, and how all the whole solar system is controlled in many ways by these chaotic tunnels. And this is how the chaotic transport can occur. And so here in this particular image is an artist's conception of some of these gravitational tunnels that are in our solar system, that connects our solar system. And this is a step forward from the Copernican view of the solar system, where in this image you can see that the orbits all of the planets all around the sun, except that they're all separated. They're all in this very classical conception of the solar system. And now 500 years later, our picture of the solar system is slightly different. And I'm using an image from the Chartres Cathedral's floor and actually has even more antiquity origin of the labyrinth, which shows that the whole solar system is really integrated. And this integration, even though in this picture, of course, is very nice and even, but actually these are generated by chaotic orbits. And it's what I call a chaotic transport that was first really discovered mathematically by Poincaré. And so let me show you how these tunnels are generated. So you start off looking from the sun towards the Earth, and here's the moon's orbit. And one of these very large orbits, that's actually larger than the moon's orbit, is what we call a halo orbit around the L2 Lagrange point of the Earth. And it is a gateway that's invisible. So each time you look at the sun or you look at the moon, you actually are looking at these gateways that are invisible. And they provide these free transport through these huge, huge tunnels. Now, this little animation will show you how the tubes of the Earth and the tubes of the moon interact to provide these low energy transport, so that we can actually conceive of putting a space station around the moon's Lagrange points in either L1 or L2, where it's very easy for astronauts to get to the moon and also come back to the Earth. But at the same time, they can service missions deep in space. So for example, in this case, we're going to look at how from the L1, the lunar L1 station there, send a spacecraft to the Sun-Earth L2, which is 1.5 million kilometers. And from there, you could actually deploy it and have it go to Mars and so on. So this yellow dot represents one of these space stations. And so as we pan out, you can see that the moon's tubes, the red tubes are like the off-ramps that allow you to leave, and the blue tubes allow you to get on to the next gateway at L2. And then here, it extends out to space. And here's the Earth's on-ramp, Earth going to L2. And so that when these tubes intersect, that's when you get these free transport. But from here, you could also deploy to the other parts of the solar system. And so that this offers opportunities that we don't have from just looking at Keplerian orbits. In the same way, in the future, using string theory, we're going to have much more powerful tunnels that will allow us to perhaps go through space-time. And that then is the possibility of going to the stars and to the galaxies. Now, let me jump. And so here's the conception, like an artist's conception. First off, just the gravitational tunnels that we're working with now, but eventually, instead of planets, it will be tunnels between galaxies.
By utilizing chaotic transport, the astronauts found a shortcut, the direct route to my planet. It makes me angry, or I should rather say, upset, that we didn't even know about this.